Hello everyone, welcome back to Know It. In this video, we are going to prove theorem number 10.1 from the chapter Circles. This is from class 10 CBSE NCERT syllabus. This is the 10th chapter and you have totally 2 theorems in this chapter. We will do the first one today and the next one we will be doing it in the next video. So here goes the theorem. A tangent at any point of a circle is perpendicular to the radius through the point of contact. Now in this figure, if you see, here is a circle and this is center O. We have a tangent here and this is the point of contact of the tangent with the circle. So now let's draw a line here. So this is the radius of the circle. Now we are asked to prove that the radius is perpendicular to this tangent through the point of contact. So we have named the point of contact as P and this is tangent A, B. So for this perpendicular lines, we have many properties. One of the property is that the shortest distance from any point to a line will be always perpendicular, or else you can say it will be 90 degrees. So we are going to prove that if both the angles are 90 degrees, then this is going to be perpendicular. So we are going to incorporate this property of perpendicular line in this circle and we are going to prove the theorem. So let's start by writing given here. Given. In given, you have to mention all the things that are mentioned in this figure. So we have a circle with center O and the tangent AB with the point of contact P. So this is what is given in this figure. Now we will be writing what is to be proved. So let's write to prove. We have to prove that this line OP is perpendicular to AB. OP is perpendicular to AB. Now we have to prove this using a small construction. For that we have to take one point in AB which is other than P. So let's take a point here, say for example it's Q. Now we will be joining OQ with dotted lines. We have joined OQ now and this point where the line intersects the circle will be called N. So we are going to write this construction here. Take a point on AB other than P named Q. Join OQ. Now OQ intersects the circle at N. Now we are going to prove it. So let's write proof. Now we can see that OP is equal to OM. Right? Because both are the radius now. So let's write OP is equal to OM. Radii of the circle is the reason. Now we can see that OQ is longer than OM. Right? Because OQ is the whole line and OM is just a part of it. So we will be saying that OQ is longer than OM. So let's write it as OM is lesser than OQ. Why? Because it is a part of the line. So a part of the line. Now here, if OM is lesser than OQ, then shall we say that OP is also lesser than OQ? Yes, because both are the radius, both are of equal length. So we can say that if OM is shorter, then even OP will be shorter. So let's write OP is equal to OA. This is the reason. Now we have taken a point here. Now it is understood that it is longer than OP, right? Because OM is the point where the line intersects the circle is M and this is the radius. Same way this is the radius. Now you have understood that this line is getting extended to touch the tangent. So now if you take any other point in the same line other than this point of contact, it is always going to be longer than the radius. So let's take it here. Then also it's going to be longer because it is getting extended here after the circle. And same way if you take here, anywhere you take, it's always going to be longer than the point of contact. So let's write here as a line that connects the tangent at any point other than P is longer than the radius OP. Got it? You may draw any number of lines here, but still all the lines are going to be longer than the radius because the radius can meet the tangent only at one point and which is P. So all other points are going to be longer than the radius. Now it is clear that OP is the shortest distance and we have already discussed that for a line to be perpendicular. Now if you have a line here and you are going to connect this line from a point if you connect it straight, only then it's going to be the shortest distance. So if you're going to connect it here, here or here, it's not going to be the shortest distance. It's going to be longer than that. So any line from a point which is getting connected to a line is always perpendicular. So this angle is going to be 90 degrees on both sides. Okay, so that is going to be the shortest distance, and since here OP is the shortest distance, OP is perpendicular to the tangent. So let's write here as, since OP is the shortest distance here, OP is perpendicular to AB. The reason is the shortest distance from a point to a line is always perpendicular. Okay, so here therefore, hence we can say that OP is perpendicular to AB. So that's how you prove it. So if you watch this video twice or thrice, you will get a hang of it and you can practice well as many times as you can so that you can do well in your exams. If you like this video, please like and share it to your friends too. And don't forget to subscribe to my channel because I have a lot of interesting and useful math videos which will be very helpful to you during your exams. So until we meet in the next video, bye-bye.